Our first lesson in coordinate geometry is going to be a review of slopes and lines. So if you look at our learning targets, I can write equations of lines based on a variety of information that would including slope, intercepts, points. Second target, I can use slope to verify collinearity or geometric figures. Third, I can use slope to calculate missing coordinates in geometric figures. So we're going to go back and talk about lots of types of quadrilaterals. And fourth, I can use coordinates to calculate perimeter and area of figures. So you can see we're going to kind of review equations of lines, which deals with slope, and then we're going to kind of apply those ideas in these three types of problems. So let's review some basics from your algebra days, right? Most of you probably think of slope as rise over run, which is fine. That translates into the change in the y-coordinates over the change in the x-coordinates. If your 2 points, of course, were x1, y1 and x2, y2, you subtract the y's and you subtract the x's. Make sure you keep them in the same order. There's your slope formula. We often, of course, call that m. Slope-intercept form of a line is the one you probably first learned, y equals mx plus b, where m, of course, represents the slope and b represents the y-intercept. Point slope of a line, that's when you're given a point, say x1, y1, and the slope m. If you have those two pieces of information, you can write y minus y1 equals m times x minus x1. This is a really useful form of a line that makes it pretty easy sometimes and quick to answer questions. So don't always feel the need to go to slope-intercept if they don't ask for it. This is probably much more useful at times. Slopes of parallel lines, we've reviewed this through the course of the year. The slopes of parallel lines are the same, right? The rise and run would be identical. The slopes of perpendicular lines, we've talked about this before too. Those are opposite reciprocals. X and y intercepts, that's where it crosses. Intercepts are where it crosses the axis. So if you are talking about an x-intercept, you are talking about where it crosses the x-axis. If it crosses the x-axis, the y-coordinate must be 0. So where it crosses the x-axis. If we are talking about the y-intercept, the x-coordinate must be 0. And this, of course, is where it crosses the y-axis. Horizontal lines, of course, look like this. They are of the form y equals some number, right? And vertical lines are these up and down lines. They are of the form x equals some number. I'm going to remind you of a trick that you probably heard before called Vux-Hoy. Vux-Hoy, a vertical line has an undefined slope and is of the form x equals. A horizontal line, this O actually is a 0 for a 0 slope, and they are of the form y equals. So if that's a little trick to help you remember those last couple, and I see that I'm off the screen here. So again, horizontal lines, y equal a number. Vertical lines, x equal a number. And here's this Vux-Hoy trick. Again, the u stands for undefined slope, and the x is it's an x equals form. And Hoy, this O is actually a 0 for 0 slope for horizontal lines, and y is it's in y equal form. All right, let's take a look at the examples. All right, some basic work with writing the equations of lines. So in part A, if we are going to find the x and y intercepts, if you look at what we just did, we talked about the x-intercept would have to have a y-coordinate of 0. So if the x-intercept has a y-coordinate of 0, I can plug that in. And if I solve, that gets me 2x equals 10, or x equals 5. So the x-intercept would be the point 5, 0. The y-intercept would be where x is 0. So if I put that in the equation and I solve, I get y to be negative 2. So my y-intercept would be 0, negative 2. Part B says rearrange the equation to slope-intercept form. Slope-intercept form is the y equals mx plus b form. So if I start out with 2x minus 5y equals 10, and I want to solve for y, I'm going to subtract the 2x over to the other side. Then I'm going to divide by negative 5. If I simplify that, two negatives make that positive 2/5 x. 10 divided by negative 5 is negative 2. There is my answer. Okay. Part C, graph the line. Well, we have lots of information to graph the line. I could use the intercepts, 5, 0, 0, negative 2. I could use those 2 points and sketch the line. I could have also used this form and said my y-intercept was negative 2 and my slope was rise 2, run 5. That would have also gotten me the graph of that line. Part D, find the equation of a line to the line passing through 3, 7. And that should say a parallel line. Oh, I guess it does say parallel line. I'm missing it in the notes here. Of a line parallel. So we know parallel lines have the same slope. All right. So if I look back up here, my equation was y equals 2/5 x minus 2. I can pick out the slope as 2/5, so I know that has to be my slope. I don't know that it has the same y-intercept, so I cannot take the negative 2, but I do know it passes through the point 3, 7. So look, I have a point and a slope. I'm going to use point-slope form. That's y minus the y-coordinate is the slope times x minus the x-coordinate. And since it doesn't specify what form to leave it in, I can leave it just like that and be done. Here we're finding the equation of a line perpendicular to the line passing through 1, 8. So we learned before that perpendicular slopes are opposite reciprocals. So again, I'm looking at the line that we rearranged to be this. I know this is my slope, so the opposite reciprocal of that would be negative 5/2. That's going to be the slope. Again, I cannot take the y-intercept. I don't know anything about that, but I do know it passes through the point 1, 8. I have a point and a slope, so again, I'm going to use point-slope form. Y minus 8 is negative 5/2 times x minus 1. It doesn't specify form, so I'm going to leave that as my answer. All right, the last example on this page says find the equation of a line passing through 2 points. We know in any form of the line I need the slope, but we have 2 points, so I can calculate the slope. If this is x1, y1, and this is x2, y2, I can do y2 minus y1 over x2 minus x1. That gives me negative 10 over 8. I want to, of course, reduce that, so I'm going to call that negative 5/4. So I have a slope, negative 5/4, but I also have points. I actually have 2 points. I can use either one. I'm going to choose this point right here, but it doesn't matter. I'm going to use point-slope form. So I'm going to do y minus 4 equals negative 5/4 times x plus 6. Or if you would have chosen this point right here, I could have done y plus 6 equals negative 5/4 times x minus 2. Either one of those answers would have been correct. You do not need to list both. All right, let's take a look at some more geometry-related examples. Here are the targets that relate to some topics we've already discussed. It says, using slope to verify collinearity or geometric figures. So example 3 says, show that the quadrilateral GHJK is a rectangle. So let's make a quick sketch. G is at 0, 4. H is at 8, 10. J is at 11, 6. And K is at 3, 0. So mine may not look like a perfect rectangle, but I can see we're pretty close. All right, so if you remember when we studied quadrilaterals, to show that something is a rectangle, step 1 is to show that it's a parallelogram, and then step 2 is to show it has one right angle. Because if it has one right angle, it must have 4 right angles. So to show it's a parallelogram, in step 1, I'm going to show that opposite sides are parallel. So I'm going to start with GH. I'm going to find the slope of GH. Notice how I'm labeling everything so I know what my calculations mean. GH would be y minus y over x minus x. That is 6 over 8, which reduces to 3/4. I know that should be parallel to KJ, so I'm going to find that one next. That slope would be y minus y, 6 minus 0 over x minus x, 11 minus 3. That is also 6 over 8, which is 3/4. So I know those lines are parallel. Similarly, I'm going to work on the other two sides. I'm going to find the slope of GK. Again, I'm labeling everything so I can see what I've calculated. Y minus y, so that's 4 minus 0 over x minus x. That is going to come out to be negative 4/3. I know that should be parallel to HJ. So if I make that calculation, that's y minus y over x minus x, 10 minus 6, and 8 minus 11. That comes out to be 4 over negative 3. Those match, so those lines are parallel. Thus, I've shown that it is a parallelogram. To show it has a right angle, I'm going to use perpendicular slopes. So I'm going to, for example, look at the slope. I'm going to pick GH. You could pick any segment. So if I look at the slope of GH, I've already calculated that. That came out to be 3/4. And then I'm going to look at the perpendicular line, one of them. I'm going to pick GK. I could have also picked HJ. And if I look at the slope of GK, let's find that. That was here. That's 4 over negative 3. Hopefully you notice that those are opposite reciprocals. So we have perpendicular lines. Thus we have a right angle. So I've shown step 2. I've shown that both pairs of opposite sides are parallel, and I've shown that I have a pair of perpendicular lines, which means I have a right angle. As part 3 here says, use slopes to calculate missing coordinates in geometric figures. So let's make another sketch. Drawings are going to be very helpful in this section. A is 2, 8, so let's put that up about here. A, 2, 8. I'll even mark the axes here. And then we have B is 9, 10. So I'm going to put that up here. B, 9, 10. So the x coordinate would be 9 and the y coordinate would be 10. And then point C was 13, 5. So I'm going to put that out here. C, 13, 5, and I'll mark the axes. Axis is 13, the y-axis would be 5. So I have this so far. So I can even guess just roughly if I want this to look like a parallelogram. I can see that my point, I'm going to roughly sketch it in, is right about here, but I don't know what those coordinates are. I'm going to use, however, this idea of slope. I do know, for example, that these two lines right here should be parallel. So I'm going to look at rise over run, knowing that it should be identical. So if I'm looking from point B to point C, my rise would be this y value right here. That's my rise. And then my run would be this distance right here. So that's my rise and my run. Well, to look at rise, that's the y direction. I'm going to look at the 10 and the 5. Those are the y values. What did I do to get from 10 down here to 5? It is a distance of 5, but remember, direction is important. I'm going from this top point down to this bottom point. So that means I went down 5. I'm going to call that minus 5. Okay? Now I'm here, so now I have to run. So I'm running over to the right. That's the x coordinates, so I'm going to look at the 9 and I'm going to look at the 13. I was at the 9 and I ran over to the 13. How far is it from 9 to 13? That's a distance of 4. Now I want to repeat that process in order to find point D. I'm up here. I want to keep that pattern to get to D. So I'm going to go down 5. Well, that means I started up here at 8. That's my y coordinate. If I'm going down 5, this D coordinate right here is going to be 8 minus that 5. Now I have to run to the right, and I know that distance I have to run is positive 4. Well, where did I start? I was at the 2. So I'm going to start with 2, and then I had to add 4 to it because I moved to the right. So the coordinates of point D would be 3, 6. That would be my answer. Oh, I messed that up. I hope you caught my mistake. 8 and the 5 down, that shouldn't have been the x coordinate. That should have been the y coordinate. And the 2 and the 4 here are the x coordinates. So this right here, I have those out of order. That should be 6, 3. Again, the green representing the y values. So I was at 8, I went down 5, so that puts my y coordinate at 3. And my x coordinate, I started at 2 and I moved over 4, which put me at 6. Sorry about that. All right, and the last example here, use coordinates to calculate perimeters and areas of figures. It says find the area of the region bounded by the x-axis, the y-axis, and this line. So let's make a sketch. I'm going to rearrange this line to slope-intercept form so that I can graph it. So I'm going to subtract the 2x, and then I'm going to divide by 3. If I simplify that, that's negative 2/3 x plus 2. So my y-intercept is 2, and my slope is rise over run is negative 2/3. So I rise negative 2 and I run 3. That gets me another point. You could have also done that with intercepts if you wanted to find those instead. So it said find the area bounded by the x-axis, the y-axis, and this line. Hopefully you can see we have found a triangle. We should see that it's a right triangle. The base of that triangle is 3. The height of that triangle is 2. It's a pretty easy triangle because it's centered here at 0, 0. So my area, which would be 1/2 base times height for that triangle, is 1/2 3 times 2. Half of 6 is 3 for that area.